No, I'll tell you. Give me a second. Start recording. All right, let's start then. Are you all fine? Can you bear with me for another 1.5 hours? Not sleeping? ठीक हो break के बाद at least?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, all right. Yes, sir. Don't worry, I won't bore you after this semester. So just bear with me for some more time. Yeah. All right. So we had just stopped at this point where we talked about that one of the very crucial issue as far as time series observations are concerned is the concept of stationarity. And so stationarity mainly refers to the point about any stochastic process, and it is about the joint probability distribution of these stochastic random variables which are linked across time. So there are certain restrictions that we impose on this joint probability distribution. And that restriction is called the stationarity assumption. And just understand this very carefully because it is very important and frequently asked questions in interview as well. So what we had talked about till now is that if you have sequence of random variable or stochastic observation which are separated by equally spaced time, so we write this. These are the outcomes of this stochastic process. They are also called as realizations. And we can refer to this anytime as yt, or if you can also think of writing it as y minus 1, y minus 2, and so on and so forth. So your time index can run from minus infinity to infinity. That's what we had talked about. But let us say that this is a time series observation where initial condition is given as y naught. And you have t number of such realizations. So these are called outcomes of this stochastic process. You can think of this as your GDP, unemployment data, stock prices, anything, any variable which you record as a time series. So, and this entire sequence in shorthand can be written as this. So for discrete variables, the variables which themselves are discrete, the probability distribution of this yt, is simply that, your joint probability that y1 takes a value r1, y2 takes a value r2, y3 takes a value r3, and so on. So let's say yt takes some value rt, where this r, or let me call it as ri, is the realized value of y in that particular period. Now, having observed these first t realizations, you can actually form the expected value conditioned on these t observations, that is, on the basis of these t observations that you have in front. you can form a conditional value or expected value of, let's say, yt plus 1, yt plus 2. And these expected value or average value will be conditioned on these t realizations of y from y1 till yt. And this is very usefully denoted or even noted as conditional expectation of yt plus I on yt minus 1, so on till y1. And this can be in shorthand written as expected value of yt plus I conditioned on t observation. Both are the same expression. And which is what precisely we want to do whenever we intend to estimate a time series model or a regression model, is that after estimating the model, we want to predict, we want to forecast the future values of y, that is dependent variable. And what we actually forecast is nothing but the conditioned value or average value. And that's why it is written in this form. So, and you can shorthand, so you have to interpret it in this manner, that conditioned on the observations, t observations that we have, expected value of t plus I, any I period lag ahead, is nothing but your this conditional expected value. All right. So the concept of stationarity is about the assumptions about this joint distribution. That is, how do we assume, one second guys. हाँ मैम, कर चुका हूं मैं. कौन सा ग्रुप में? कर चुका हूं मैं. कैसे होंगे? मैंने ऑलरेडी व्हाट्सएप ग्रुप क्रिएट किया था और उसमें 20 स्टूडेंट्स हैं. हाँ हाँ, तो आप मुझे एक बार क्वेरी भेजिएगा कि सारा मैंने व्हाट्सएप क्रिएट कर दिया है. हाँ हाँ. हेलो. Yeah. So sorry. Where was I? What was I talking about? I'm really sorry, forgot.
Joint distribution. So
you will talk about stationarity now.
Yeah. So stationarity is about the joint distribution of these realizations of the variable y, which are linked across time. So stationarity is an assumption on the joint distribution or joint probability distribution of these realizations. Now, precisely what and how do we define a stationary time series process? That's what we will look ahead. So I'll define it formally and then we can discuss it. So a stochastic process which has a finite mean, so having a finite mean and variance, is called covariance stationary, or it is also sometimes referred to as weak stationarity or weakly stationary. If for all t and t minus s, that is s, so s is your lag. So a stochastic process having a finite mean and variance is called covariance stationary or weakly stationary process if for all t and t minus s, expected value of yt is equal to expected value of yt minus s is mu, expected value of yt minus mu square is equal to expected value of yt minus s minus mu plus square is equal to sigma squared y, and expected value of yt minus mu into yt minus s minus mu, which is the covariance of yt with yt minus s, is equal to yt minus j minus mu. Now let me explain these three conditions one by one, and then we can go ahead. So what it says is these are the conditions that if there is a stochastic process which has a finite mean and finite variance, it will be called a covariant stationary or weakly stationary process if for these two time period t and t minus s, it is separated by s, so s is a lag. So expected value, that is average value of yt, and average value of yt minus s is mu. Can you notice something over here? This mean is independent of time. There is no t subscript in the mean. And that's why we call it as a constant. That is, जो जिस पीरियड का ऑब्जर्वेशन है आपके पास, जो डेटा आपके पास ऑलरेडी है, उस पीरियड का आपने जो मीन निकाला, that mean should not be different for the forecasted period or for any other period as far as the variable is concerned. This is what is mean by expected value of yt and yt minus s should be a constant and it should be independent of time. That is, a mean should not have or or it change with time. Your average value of the time series variable must be constant, must remain constant for across the time period of observation. Second is the variance of this time series variable. Again, yt का और yt minus s का दोनों का variance should be independent of time and it should be a constant. Now, this is very important. Can someone tell me what this entire expression tell you? Anyone? Can you give it a try?
Deviation from
Come again.
a deviation from
How is it deviation from Mohit?
So the covariance,
Correlation coefficient.
It's not correlation coefficient.
the covariance between the two time period would be equal to the expected value of any time period that we would be taking, and the expected value of the any time difference, the expected covariance between the any two time periods that we would be taking.
No. Just look at the subscripts, guys. The answer lies in the subscript.
So what is J?
Think of it. J is another time.
Another time, right? Okay.
Yeah. Anyone?
Is it the covariance of yt when we take s one lag variable, which will be equal to the covariance when we take two lag variables?
No. Take it as an example. Suppose आप कोवेरियंस ऑफ y1 with y2 निकाल रहे हो, ठीक है. Let me call it as yt, let me call it as y, or let it be yt plus 1, yt minus 1, ठीक है. सो इसका मान लो कोई भी कोवेरियंस आता है, सपोज लेट मी डिनोट इट इज बाय दिस गामा 1. सो think it to be y2, think it to be y1. What it says, that covariance of y2 with y1 must be equal to, you see this j is equally subtracted from both the sides. So what it says is that now if I take covariance of y1 with y0, or y3 with y2, y10 with y11, y11 with y12, y minus 1 with y0, and so on, all such lag which are separated by just one period lag, covariances must be same. And here you see this S, what it says, that autocovariance of a covariance stationary time series variable will only depend on lag. So covariance of y1 with y2 जो होगा वही covariance y4 का y5 के साथ, y3 का y4 के साथ, y100 का y101 के साथ. Similarly कोवेरियंस y1 का जो y3 के साथ होगा, that should be equal to covariance between the two time period which are separated by two lags. So this last condition tells you that autocovariance or covariance of a weakly stationary time series process is independent of change of time origin. Meaning which, कि आप पूरे प्रोसेस में, entire observation में, if you are taking the autocovariances which is for lag 3, so autocovariance of y1 with y4. Now, the autocovariance that you get for y1 with y4 separated at lag 3, it must be same for all those autocovariances which have a lag 3. That is y2 का y5 के साथ वही same covariance होगा, y4 का y7 के साथ same covariance, y10 का y13 के साथ same covariance होगा. So what it says is, in a nutshell, that a time series is covariance stationary or weakly stationary if its mean and all autocovariance will automatically become variance when you're taking when you're taking no lag. That is when you're taking the autocovariances of the same variable. So in a nutshell, a time series is covariance stationary if its mean and all autocovariances are unaffected by a change of time origin. Is this clear, guys? Is this last condition clear?
No, sir.
कहाँ पे problem है?
So I didn't understand, how did you interpret it?
Okay, tell me where you find difficulty. I'll start from there. Do you understand this term?
Pardon, sir?
You understand this term, this expression?
Yes, sir. But
What
I
is-
didn't get this expression is equal to EYT minus J
ये
and minus J minus S.
राइट? ये J क्या है? This J is one particular constant, one particular time which you take for all this, time period. So imagine this as, let's say, y2 और ये y1. तो यहां पे t अगर आपका 2 है तो s क्या हो, लैग क्या हुआ आपको इसमें? What is the lag here? Can you hear me?
Yes, sir, we can.
What is the lag here in this?
Sir, S.
S, right? Yt minus t minus s. So s period का lag है. So suppose this is your y2 and this I say that s is 1. So this becomes my y1.
Yes, sir.
ठीक है. अब अगर ये y3 होगा तो ये क्या बन जाएगा आपका y2,
Yes, sir.
राइट? अगर ये आपका y10 है तो ये क्या बन जाएगा y9, राइट?
Yes, sir.
And if I give you s is equal to 2, that is if lag is 2, so if this is y10, this will become y8. If this is y2, this will become y0, and so on and so forth, all the 2 period lag, right? कोई problem?
No, sir.
Okay. Instead of t, I have written here as t minus j. That is, I have changed the time origin and kept the lag to be same. So जहां पे t था वहां पे आपका t minus j है. So अगर ये कोवेरिएंस, मान लीजिए suppose I tell you that this yt minus j is, let's say, y minus 11. And you're talking about 1 period lag. So this will be your y minus 12. Similarly, if this is my y 100, this will become y 99. So t and t minus j are two different time. But the covariances term that you're finding out is separated by the same lag. So what it says here is that no matter whether you're trying to talk about the covariance between yt and yt minus s or yt minus j and yt minus j minus s, as long as they are separated by the same lag, their autocovariances will be same. Is this clear?
Yes, sir, got it.
So as long as the lag is same, as long as the two outcomes of the time series variable are separated by the same lag, their autocovariances must remain same. ठीक है?
Sir, I
हाँ जी.
would we study archgauge?
या आर्चगाज पढ़ेंगे.
So my question is that when we tried to optimize that archgauge model, like we did it in one of the projects, so what exactly we saw there was that the mu that we were getting for our series and compared to, like, when we took that conditional variance into consideration, so the mu were different for both the series. Like our optimized mu was different from what we were getting for the series in the single wo. So according to what you are telling us is like, if it is independent of the time, so then why were the mu's differing in the two calculations?
Your answer lies in your question. It is conditional heteroscedasticity.
So because we conditioned it on the past errors, that is why we were getting a different mean.
No, you see, conditional जब हम covariance stationary मानते हैं, हम ये जो second term है आपका, what you say is the variances remain same across all the time period. So arch process में क्या होता है, जो आपका residual term होता है, that is the variance of unconditional variance of that residual remain constant, but conditional variances change. And what basically it means that there's some sort of clustering happening. कि वन पीरियड अगर मान लीजिए किसी पीरियड में बहुत ज्यादा बूम है तो उसका नेक्स्ट पीरियड भी ऑटोमेटिकली बहुत बूम में होता है. सो व्हाट इट मींस इज द करेंट पीरियड ऑफ रेसिडुअल इज गेटिंग अफेक्टेड the most by its previous period residuals, and not just the value, the variability of that residual. So that's why you model it on the basis of that period variances. So that's where you assume for the variances of the residual term as a function of variances of the previous year or previous lag residual term. But unconditional variance of the error term remains constant. So इसको आप basically ऐसे समझ सकते हो example के तौर पे कि suppose there is a long run investor and there is a small there is a short run investor. I am a person who has invested let's say 1,000 rupees in a stock and he is least bothered कि बीच में क्या होता है stock का. अगर मुझे 5 साल में ये stock 10% return दे रहा है then I am fine with it. So I put my money in this stock and I just sleep. अब वो स्टॉक अगले साल 900 पे रहे, चाहे 600 पे रहे, चाहे 1000 पे रहे, इट डज नॉट मैटर टू मी. What matters to me that at the end of 5 years, I must get a 10% return, whatever the target would be in the mind of investors. So in that case, what you say, so that is the time which you say that unconditional variance is constant. That is over the longer period of time, the variability of the stock return remains or more or less same. Whereas for a short run investor, if let's say I have invested my money in this stock for a month, I'm definitely worried about what happens to the variability in the prices or the return on this stock for this, for within a month. So उस केस में जब मैं रिटर्न्स को मॉडल करूंगा या जो मैं प्राइसेस को मॉडल करूंगा, उस केस में उस पीरियड के वेरिएबिलिटी पे मुझे मॉडल करना होगा. And that's why arch models are used, which basically talks about when your error terms are not just autocorrelated but they are also heteroscedastic. Heteroscedastic means what? कि there's some sort of clustering happening. एक previous error residual इस error के residual को और influence कर रहा है. So अगर एक period में stock prices बढ़ रहा है तो next period भी बढ़ेगा क्योंकि influence बहुत ज्यादा वहां पे variability को impact कर रहा है. Whereas this three conditions that we are talking about is what we imagine or or what you can think to be an idealized condition. कि आपका टाइम सीरीज वेरिएबल अगर ये तीनों कंडीशन फॉलो करता है तो वो एकदम आइडियल वेरिएबल. दैट इज इट हैज अ मीन जीरो इंडिपेंडेंट ऑफ मीन कांस्टेंट है इंडिपेंडेंट ऑफ टाइम है, वेरिएंस भी कांस्टेंट है अगेन इंडिपेंडेंट ऑफ टाइम है, और जो ऑटो कोवेरिएंस है वो सिर्फ अपने लैग पे डिपेंड करता है. दैट इज इट इज सो इसका ऑटो कोवेरिएंस लैग पे डिपेंड करने का मतलब क्या हुआ कि अगर मान लो इन द ऑब्जर्व पीरियड और फॉर द डेटा दैट यू हैव, if the auto covariance at lag 1 is let's say some value, but for the forecasted period if the auto covariance at lag 1 is not constant or it depends on the time period at which you're observing, then your model goes for toss because you're not able to predict anything. So that is what these three conditions are there for, imposing a time series variable to become stationary. And these three conditions are combinedly also referred to as covariance stationary process. ठीक है? Is this clear till here, all of you? Shall I go ahead?
Yes, sir.
Stationarity clear है? Stationarity मतलब क्या हो रहा है?
Yes, sir.
All right. So stationarity means कभी भी अगर आप सबसे पहला चीज as usual जब भी आपके पास कोई डेटा होता है you plot the data. So Same thing you do with time series observations as well. You plot them, and then you know बहुत सारा चीज आपको ग्राफ से ही पता चल जाएगा whether the data is stationary or not. So by just looking at these three conditions, the first thing that should come to your mind as far as graphical analysis of testing for stationarity is concerned, that you know if your data, if your data looks somewhere like this or like this, in both of these data, somehow it shows a certain kind of trend going on. So suppose this is time 0, this is time 100. What it means is that over the time period, the average value of the variable has gone up. And this is what you generally refer to as trend. In this particular data, your average value of the observation has gone down. So this will be called your upward trend. This will be called your downward trend. A common example would be for this would be your GDP data. Definitely gross domestic product of a country is bound to go up as time increases. So mostly GDP data of any economy that you have, mostly it will be non-stationary. This is the first, intuitive test for stationarity, just by looking at the data. Again, if your data somewhere, looks like in this manner, or if your data goes like this, what it tells you that not only mean is going up, but also the variability of the observations across time period is not roughly constant. Thus, it violates the second condition. That is, not only mean is not independent of time, also variance of the series is not independent of time. It is dependent on time. So usually graphical analysis of testing for stationarity looks at these two main points, whether the graph shows any upward or downward trend, or it shows any variability which looks like as a function of time. If it is, your variable is not stationary. If it is not, then more or less from graphical analysis, you can proceed ahead and say that your data is stationary.
So,
yeah.
So for the first condition, how do we check that the mu is independent of time?
You see, data अगर आपका stationary है, and suppose this is the mean value, so no matter how much it goes up or down, it must more or less return to the same part. Let's say this is the time period under observation. So अगर आप average, that is, it should not have more or less a trend. अगर आपका average mean क्या है? Mean is the average value, right? तो अगर एवरेज टाइम पे चेंज हो रहा है या तो ऊपर जा रहा है या नीचे जा रहा है, ऊपर जाएगा इट मींस योर डेटा मोर लेस लुक लाइक दिस, नीचे जा रहा है इट मींस योर ऑब्जर्वेशन looks like this. But if you have certain observation where the average value for the entire across the observation remains constant, that is जो यहां पे था वही एवरेज वैल्यू यहां पे, that's what you mean by average or mean of the series to be independent of time. That is, there will be no such trend or observable trend in your data.
Okay, so got it.
ठीक है? All right, stationarity clear? अगर नहीं है, again I repeat this because this is very very important. बहुत ही ज़्यादा frequently asked question रहता है, कहीं पे भी कोई भी आपसे पूछ सकता है ये बात. And mostly, see, strong stationarity I'm not discussing because that's a very complex restrictions that are imposed on the time series variable, and that is not only also feasible. So what strong stationarity means? Strong stationarity says that all the moments of distribution of this jointly distributed random variable, stochastic random variable, they all are independent of time or time of origin. It means not only mean and variance, that is not only first and second moment of the distribution, all the other higher order moments of distribution of this jointly distributed stochastic variable is independent of time. That is a very strong assumption to be met in practice as well, but this is what strong stationarity assumption refers to. But mostly we'll concern ourselves with covariance stationary series, and covariance stationary series is all about that its mean and all the autocovariances are independent of change of time of origin. That is, it is not affected by any change of time origin. Is this clear, guys?
Yes, sir.
All right. After having defined autocovariance and the conditions for stationarity, for a covariance stationary series, we also define autocorrelation. And the autocorrelation is defined as covariance at lag divided by variance of the variable. I'll repeat, autocorrelation is defined as ratio of two covariances, where in the denominator you have covariance at lag 0, and in the numerator you have covariance at particular lag for which you are finding the autocorrelation. So if we are trying to find out the autocorrelation between yt and yt minus s, your autocorrelation at lag s will be equal to covariance at lag s divided by covariance at lag 0, which is nothing but your variance of y as well. Is this clear? Is this
Could you explain? No, could you explain covariance of lag?
अभी हमने covariance निकाला था ना?
Yes, sir. Sir, so we are taking just the lag value, and then within those observations of the data, we are taking the covariance of the, like how exactly we would need that yt also, y naught also, no?
Y naught is your variance, no?
Yes, sir. So like the covariance would be between our original series and so CD and the lagged CD, no?
No, please ask again. I didn't get
Sir,
what you asked.
covariance would be
Yeah.
between our original series and the lagged series, right?
It's not about the series. Yt and yt minus s is the observations of the same time series.
Okay, got it.
That is, अगर मान लो आपके पास y1 से लेके y10 तक observation है, and then auto covariance of y4 with y1. This will be auto covariance at lag 3, right?
Yes, sir, got it.
ठीक है. So अगर मुझे auto correlation at lag 3 निकालना होगा, so first I need to find out the auto covariance at lag 3. I'll divide it by the variance of y.
So the variance is constant, right? Which we started in the stationary.
Yeah.
Okay.
ये पॉइंट क्लियर है?
Yes, sir.
All right. हाँ जी.
I lost my connection a while ago. Auto correlation से मुझे समझा नहीं सर.
हाँ, कहाँ पे नहीं समझा बताओ.
Auto correlation वाला पार्ट आपने जब स्टार्ट किया तभी से I lost connection.
Okay, no issue. Can you see this formula?
Which one sir?
ये रो S वाला.
No sir.
You can't see the screen?
I can see the screen, but row is yeah.
Right. So what I defined as that auto correlation for a covariance stationary series is defined as ratio of autocovariance at that particular lag divided by autocovariance at lag 0. So autocovariance at lag 0 is automatically your variance, and autocovariance at lag s you can easily calculate by the covariance formula. So autocorrelation at lag s is nothing but ratio of autocovariance at lag s divided by variance. समझा?
यस सर, थैंक यू
नहीं
सर.
नहीं आया समझ में तो एक बार फिर से रिपीट करूं?
अब काफी समझ आ गया सर, बट यस प्लीज रिपीट. थोड़ा वो वाई नॉट वाला पार्ट नहीं समझ.
ये देखो, this is your covariance of yt with yt. Lag means what? yt and yt minus s. ये मेरा दो टाइम पीरियड है where s is the lag, right? So if I am saying that covariance at lag 0, it means s is equal to 0. So if you are taking the covariance of yt with yt, it is nothing but variance of y. नहीं है ना? अब yt minus s is what? That s lag. So अगर मान लो मुझे कोई बोलता है that auto correlation at lag 3 क्या होगा इस stationary series का, so that I'll calculate by first finding out the auto covariance at lag 3. I divide it by the variance of the series.
यस सर.
ठीक है?
हाँ जी, समझ गया. थैंक यू सर.
All right. Now, since both these auto covariances are time independent, it automatically means that your auto correlation will also be time independent. नहीं? ठीक है? And it will also be lag dependent. That is, auto correlation between yt and yt minus 1 will be same as yt minus 1 and yt minus 2, or yt plus 1 and yt, where they are separated by one period lag, because autocorrelation depends on lag. Is this clear to all of you? नहीं?
So can you please repeat?
Yeah. Yeah, right? This is time independent. This is time independent. So autocorrelation will also be time independent.
Yes, sir.
Autocorrelation also only depends on the lag.
यस सर.
ठीक है? So जो ऑटो कोरिलेशन yt का yt minus 1 के साथ होगा, how are they are separated by one period lag?
Yes, sir.
वही ऑटो कोरिलेशन yt minus 1 का yt minus 2 के साथ भी सेम होना चाहिए.
Yes, sir.
और फॉर दैट मैटर yt और yt minus 1 का जो कोरिलेशन होगा, वही कोरिलेशन yt minus s and yt minus s minus 1 और j minus 1 का होना चाहिए, where they are separated by just one period lag.
Yes, sir.
ठीक है? Guys, is this point clear?
Yes, sir.
यस सर.
Yeah. So for a covariance stationary series, your autocovariance, autocorrelation, mean, all these first and second moment of distribution are independent of time. This is what you mean by a series to be stationary. If a series is not stationary, either its variance is not constant across time, or its autocovariances are not constant across time, or its mean is not constant across time. Is this point clear?
Sir,
Haji.
in which situations will the mean and the variance be dependent on time?
You can have any situation, suppose you have a variable and let's say the data after plotting it looks like this. So in this case, what you notice is that for this time period, this time period, this time period, एक तो सबसे पहले you should notice that you should be able to notice that there is some sort of trend you notice. That is, the average value of your series has gone up with respect to time. Constant होने के लिए ये average value should be same across all the time. Second thing is the variability. So what we notice is that to start with, the variance of this observation for the, for some time period is smaller. And as time progresses, variability of the observation also increases.
So the mean will be dependent on time only when I calculate the mean for the different time periods. If I take all of the data points and then calculate the mean, it will be constant, right?
But why it should be? अगर मान लीजिए आपका मीन itself is one second, एक बार तरुण को फोन करके बोल दे क्लास में हो. If your mean itself has a trend component, something like let's say let's say let us say I'm talking about 100 last 100 innings scored by a particular batsman, and I take the mean of, let's say I take let's say 10 10 inning का करके हम mean निकालते हैं, so I get 10 means like this. And what if you notice that as the time has progressed, due to either becoming a consistent player or becoming more improved player, the average score scored by the player has kept on increasing as the time has progressed ahead. So in that case, your mean itself shows a trend. Another example would be your GDP value or any macroeconomic variable where that is not bound to go down mostly. So as as more and more number of people, or as economy size increases with time, also GDP also increases. So in that case, even if you calculate the mean of the series, what you notice is that there is some sort of trend in the mean itself you get. Now, what it means is that suppose you had, one second. Now, suppose you have data points still here. And when you plot the observation, it comes like this. Suppose. Now, when you take average of this observation it more or less looks constant. This is what we mean. First of all, we mean by mean to be constant, that is, it does not change on time. But if for the same series, you would have got an observation which looks like this. Or which goes downward. And then if you calculate mean, what you notice is, so this is just a simple graphical analysis. What you simply notice is that with time, so suppose you calculated mean till here first, then you calculated mean till here, then you calculated mean till here, and then finally, so what you notice is that for each time period, your mean also has increased, that it has not remained constant throughout the observation. And that's where what you are able to conclude is that your mean is not constant, but it depends on this trend component, or there is some trend component in the data. So बहुत बार एक remedial measure इसका ये होता है कि क्या हम करते हैं t को, that is time को और trend को independently अपने regression में run कर देते हैं. So many times you simply regress GDP on trend, and what you get is the estimated coefficient gives you that trend component. Many times people do this to make the data stationary. So mean not being constant means with time, as time has progressed, the values taken by the variables have increased. And why do I need it to be constant? Suppose I had the data points still here, but now let's say I want to forecast for, let's say, 5 period or 10 period ahead. Now, if my mean continues to have a trend component, in order to have any feasible forecast or any feasible prediction, I must include the trend component in my prediction. Otherwise, my prediction is not true. And that's why when you check a series for stationarity, you check whether it is, it has a trend, or, the variances are not constant, or there is this element of seasonality. So you look for various components of a time series which can contribute to the non-stationary part of the series. Trend is just one component where you can actually conclude that average value of the series has not remained constant. Seasonality is one such thing which adds to the element where variances do not remain constant. Seasonality is very much talked data when when you have, let's say, sales of refrigerator or air conditioners, or any product which depends on seasons, like for Indian economy in particular, sales during October and November, which mostly marks the festivities, sales of almost all the companies show a tremendous growth. So seasonality component adds to the non-stationarity in the variables, where the variances do not remain constant. So this is precisely what we mean by mean not remaining constant across time.
So, sir, for simple graphical analysis,
Haji.
we can distribute the graph in equal parts, and we can assess all means of all those parts.
Correct. You might also have data which looks like this.
Yeah.
You might also have data which looks like this, which is a typical time series data. So what you notice in this case is that, for this particular part, you see going down, then again going up, then again going down, again going up. So mostly it tells you, if you just draw a trend line, जो हम Excel पे moving average करते हैं, वो क्या करते हैं? We just try to draw a trend line, we just try to smooth the data. So इसमें हम क्या करेंगे? Suppose we take a moving average, let's say order 10 or order 6. So what it will do, it will club, the first sequentially all the 5 observations together and find out the average values, and that's how data gets smooth. So moving average is just a process to take out the trend component of the time series. Is this clear? What do we precisely mean by non-constant mean?
Yes, sir.
Yes, sir. So could you scroll up a bit
हाँ जी.
to the examples we took?
Yeah. यहाँ?
Yeah. So in these examples, we took lag as 1. I did
जी.
not get what point did we establish from this.
No. I just gave an example. You can take lag at 2, 10, 20, whatever you wish, Bhushan.
Okay, and this was for the autocorrelation part only, like the
Yeah.
autocorrelation. Okay.
Yeah.
Okay.
Is this clear, all of you? स्टेशनरिटी का इम्पोर्टेंस इसीलिए क्योंकि अगर आपका सीरीज नॉन स्टेशनरी है तो मोस्टली जो आपके फोरकास्ट होंगे या जो आप मॉडल बनाओगे दोज विल नॉट बी अ टेनेबल मॉडल. Sometimes you can also lead to a phenomena of spurious or nonsense regression because your series might be non-stationary. So एक बहुत ही spurious regression का एक बहुत ही फनी एग्जाम्पल है यूएस का जीडीपी डेटा के साथ नंबर ऑफ सनस्पॉट्स ऑन अ पर्सन's फेस. So when it is being regressed on, when US GDP data is regressed on the number of accumulated sunspots, it shows a sufficiently 99% R square, which is entirely untrue. So when further investigation was there, so it was found out that both these numbers they themselves have a trend component. That is, it was not that the number of accumulated sunspots on a person's face is contributing anyhow to US GDP. Both have a trend component, and it is that T, or it is that time which is leading to this spurious regression between the variables, and that's why having a stationary time series is very, very important. Am I clear? Yeah.
So doing a forecasting of a time series data by using the linear regression model would be a faulty regression, right?
Come again, knowing?
So doing a forecasting
Yeah.
of a time series data
Yeah.
using the linear regression model would be faulty.
Correct. And if at all you wish to use a linear regression, then you must have a trend component just to check for the stationarity. So that's why I keep on harping on this point that whenever you have a time series observation, first and foremost you check for stationarity, because almost all the model that you're in, so even these models, Arch, ARMA, ARIMA, whatever models that we have as far as time series estimation is concerned, they all are examples of stationary time series model. There are also techniques of dealing with non-stationary time series models, but these techniques, ARMA, ARIMA, Arch, more or less, if you see, they also somehow a replica of linear regression model only. AR model is a true replica of what we are doing in the linear regression model, provided that instead of x's now we have the lag values of the dependent variable itself as an independent variable. So as far as linear difference equation, as far as stationary time series are concerned, all these models which you have, they all are stationary time series models. Okay, shall we go ahead?
Yes, sir.
All right. So after having talked about the stationarity, there are various tests that we do for stationarity. The first method is generally the graphical method. We plot the data and check whether we have any trend component or seasonal component. Before that, let me just talk about these components of time series. So basically a time series observation mostly has three components. First is a trend component, if at all. Then you have seasonal component. अगर है आपका data वैसा तो it is not necessary that all the time series will have these components. And then finally you have irregular components. Irregular components are precisely those components which are due to the fact that error terms or residual terms are there, that is that epsilon. Trend component is somewhat also called as deterministic part. And seasonal component again is due to the seasonality factor. So these are the various components. So in the traditional econometrics studies and teachings as well, the major goal of econometrician was to simply forecast the time path of a variable. But as there were progress in many of the studies, now the first thing that as a researcher people do is to break the components, break the time series variable into into these three components. Because breaking the time series into these three components, you can exactly estimate trend and seasonal component, and then you just need to worry about this irregular component, which anyway you cannot have in control of. So breaking the time series observation into its singular components help you to correctly estimate the path of the variable in future, because you are able to control for the trend part, you are able to control for the seasonal part. So ideally क्या होता है method, आपके पास डेटा आता है, उसका स्टेशनरिटी चेक करते हो, अगर ट्रेंड है तो आप उसको ट्रेंड हटा देते हो, सीजनल है तो सीजनल हटा उसको डी सीजनलाइज कर देते हो, डी ट्रेंड कर देते हो. Then you simply run a model. After running the model, after getting the value, you simply add these trend and seasonal component again into the forecasted value. This is the usual method of going ahead with the time series estimation.
Sir,
Yeah.
isn't there also a cyclical component?
Cyclical component, more or less, yeah, you're right. But cyclical component is something which is defined over longer run, there. It is very difficult to find out cycles or cyclical component of a time series. Seasonal component is such that which repeats itself in a given time period, let's say in a year. Whereas cycle ka koi, there can be a 100-year cycle, there can be a 10-year cycle, there can be a year cycle. That's why cyclical component I have not mentioned here, but definitely there are cyclical components as well. But that is defined over a longer horizon.
Okay, sir.
Huh. So the usual method of detecting the stationarity of time series, पहला तो method हमने देखा, the usual graphical method, we simply plot the data. Then next is what is very famously called as Dickey-Fuller test, or it is also sometimes called as unit root test. And there are other tests as well, KPSS test, then your Phillips-Perron test. So these all, we'll just discuss the logic behind all these tests and just look at the commands on R for other tests as well. And one modification to Dickey-Fuller test, which is also called as ADF, which is augmented Dickey-Fuller test, to detect the presence of stationarity of the series or not. Other most commonly used method, which is also called as plotting the ACF function, that is your autocorrelation function. And that is exactly what you plot the autocorrelation at various lags against the lags. And the graph that we get in this is called as correlogram. which we'll discuss when we talk about how do we exactly go about ACF and PACF function. So basically these are the three well-defined methods of detecting the presence of stationarity. After we detect the presence of stationarity, we need to make the data stationary. Now, in order to make the data stationary, we have various process. अगर आपका data में trend है, तो either we make it trend stationary. If your data has seasonal component, either you deseasonalize it, and one of the very, very useful method of deseasonalizing a data is called your differencing the data, which is what mostly when you have ARMA and you need to difference the data, it is called as ARIMA model. So auto-regressive integrated moving average model it is called. So अगर आपका data में seasonality है, you need to difference the data, and how much differencing you need to do. Again, that is a very tedious task to do manually, but thankfully we have all these automated command on R which we'll use, which tells us how many differencing actually we need to do in order to make the data stationary. So, so either you do differencing or you simply have, if you have, let's say, seasonal component, you can also use dummy variables to deseasonalize the data. So either you make the data trend stationary, you deseasonalize it, and then you run the model on the stationary variable or the stationary time series. And once you get the estimated value, you again add the trend and the seasonal component to get the actual value for the forecasted period. This is what the common methodology is. Is this clear till here? I have not discussed anything, but I have just told you what are the various methods to go about it. यहाँ तक कोई दिक्कत? Guys, at least respond. है, नहीं है, क्या है?
No, sir.
So just one question.
Yeah, please go on.
Sir, it's regarding goodness of fit. So like how in regression we have, we have an R square and all.
Correct.
We have a mean square error, etc. How do we measure the goodness of fit when it comes to the ARIMA mark?
Same thing here also. See, जितने भी model diagnostic है, more or less they all remain same. You get the forecast, you get the forecasting error, find out the standard error of this forecasting error, and check whether it satisfies or it justifies the assumptions of normally distributed error terms or not. If your errors,
So basically,
yeah.
So basically we are back to our p-values, etc.
Come again. Your voice actually through echo हो रहा है.
So would there be something like a p-value for this?
Yeah.
Like how in regression we have to check for the p-values, etc. Right?
P-values. Obviously, more or less. P-value is mainly used for the overall test of significance, which are reported with the software. Okay. Here, what I'm saying is that after you have run the model, जो भी आप forecast करोगे, so the best way, or you can say one of the most important way to check whether you have run the correct model or not is always to go with the analysis of residuals. You calculate the residuals, you check for the probability distribution of residuals. अगर आपका residual में कोई finite pattern दिखता है, it means your assumptions are violated. And if if there is no such pattern to be observed in the error terms, then almost all your assumptions are true. So that's how we go ahead in this as well.
Okay, sure. Thank you so much.
Yeah.
So,
Haji.
You said for a given model to be stationary, first we need to detrend it or deseasonalize it, and then again include the trend and the seasonal to find the actual value.
In the forecasted value, yeah.
Yes, sir. So do we compare the stationary model and the trend and the seasonal models?
No.
And then come the forecasted value?
No. You see, comparison का नहीं है यहाँ पे. The idea is that forecasting using a non-stationary mean and non-stationary variance is of no use. So what we do is, अगर हमारे पास non-stationary data है, पहले उसको हम stationary कर लेते हैं, either through detrending or through de-seasonalizing. We keep those component. ठीक है? And then using the model, जो भी आपका predicted value आता है, उस predicted value में you add these trend or seasonal or both of them to get to the actual value, so that you actually are able to estimate it correctly. समझ में आई?
Sir, I'm still confused.
हाँ बोलो ना.
So you're making the model stationary and then again adding the trend and the seasonal component.
Yeah, in the final step. See, when you run, ठीक है, when you run this, suppose your data was not stationary, your data had a trend, आपने उसको detrend किया, आप इस equation से you get to these estimated values, right?
Yes, sir.
Now, if you just report this estimated value and your data has a trend, so ये estimated value क्या है? This estimated value will be constant across time. But if your data itself has a trend, for the next 5 time period or 10 time period or 2 time period, whatever trend that is there, that must be included in the estimated values that you have got.
Okay, sir, got it.
कि मान लो जो ट्रेंड, तो आपने सपोज ये वैल्यू आया 12, आपका ट्रेंड कंपोनेंट है 1.39 एंड सीजनल कंपोनेंट कुछ नहीं है, सो आप क्या करते हो, 12 प्लस 1.39 करते हो फॉर द नेक्स्ट पीरियड फोरकास्ट. दिस इज व्हाट इट इज डन.
Got it, sir. Thank you.
ठीक है
Sir,
हाँ जी.
how can we relate correlation and this trend apart? Like, does it necessarily mean that if there is a high correlation, there is a trend between the two variables?
See, trend is with respect to the time.
Okay.
है ना. ट्रेंड मीन्स क्या हुआ, जो भी आपका if you're talking on mean, that is average values changing with respect to time. So basically what it means is कि जैसे जैसे टाइम बढ़ते गया, जो वैल्यूज हैं, जो इंडिविजुअल वैल्यूज हैं वेरिएबल के, वो मतलब ज्यादा होते गए. दैट्स व्हाई योर एवरेज वैल्यू हैज गॉन अप. So trend mainly is about how it has moved across time. So एक वे तो क्या होता है कि आप उस वेरिएबल को against t, that is keeping t as one of the explanative variable, you run it. और जो भी estimated coefficient आता है वो आपका trend component बन जाता है. That is जितना भी इस वेरिएबल में मूवमेंट है, the coefficient explains that percentage of movement in the variation of dependent variable is explained by this trend component. समझ में आई ये बात है?
Sir, again, like because if like I'm getting this 1.39 as my trend component, so because of like as the time is moving up, so my whatever would be my mean value would be increasing by this much amount.
Correct.
If there was no trend and if there is trend, it would be moving up by this much amount, right?
Correct.
So if like I'm taking 10 years data for say for any variable for that matter, and if I'm seeing like say again ki when there are summers, so like basically there could be correlation between two variables also over a period of time that goes upward. So again, because like if I'm taking a data for a larger period, not just like because I want to include that time factor into it, but if I'm taking for a large period and still those two variables are positively correlated with each other. So my question was ki like, is there any relationship between these two things? Like, how trend and correlation can like, give us some information about the data set that we are dealing with.
Correlation amongst what?
Any two variables over a very long period of time.
But correlation only gives you that linear relation.
Okay.
Correlation.
And this trend will be taking all the fluctuations into consideration and
correct.
Then this, okay, all right.
Correct. Trend तो इसे मान लो जैसे एक एग्जांपल ये ले सकते हो दैट प्री 1991 और पोस्ट 1991 जब इंडियन इकोनॉमी लिबरलाइज हुआ, सो प्री 1991 जो ट्रेंड होगा कंजम्पशन का और पोस्ट 1991 जो ट्रेंड होगा कंजम्पशन एक्सपेंडिचर का, दैट माइट बी वेरी डिफरेंट. And if you just if you have a data which is from 1960 and till 2020, then what you notice is that this data will show more or less an upward trend. Assuming this data will show more or less an upward trend, and this trend just tells you that your average value is not constant, or that is for this particular series. This taking account of all the factors, your average value has gone up as time has progressed. Whereas correlation amongst variables only and just only talks about the degree of linear relationship. कि अगर ये वेरिएबल मूव कर रहा है तो वो वेरिएबल मूव कर रहा है, यू नो, बट इट डज नॉट गिव यू कि इसके कारण ये मूव किया या उसके कारण ये मूव किया. इट डज नॉट गिव यू द डायरेक्शन ऑफ दैट रिलेशन. It just tells you that two variables are correlated. In that case, in that sense, you can find a very high correlation between, let's say, it's inflation and let's say Virat Kohli's century. If both of them have more or less moved together in tandem, you can definitely get a very high correlation, and that just gives you an indication that, you know, whenever one variable has moved, the other also has moved, but it necessarily need not cause that thing. And one of the very classic case of correlation not revealing any more information than the linear association is that smoking causes lung cancer. There is definitely very high correlation between them, but you simply cannot hold smoking to be cause of lung cancer. So correlation सिर्फ और सिर्फ तुम्हें linear relationship के बारे में बताता है, nothing else.
Okay, sir.
Whereas trend component tells you that the time series variable that you're dealing with, the average value of the time series variable has changed, that it has not remained constant across the entire time period under observation. All right?
Yes, sir.
Okay. So stationarity, again, very, very important. What type of stationarity? Covariance stationary series चाहिए मुझे. Covariance stationary series means mean and autocovariances of the time series should be independent of time. चलेगा?
Yes, sir.
All right. So let us just try and look for an example on R. Just give me 10 minutes more. I'll just help you out with how to store a variable in the time series format on R, and then we can break and we can meet tomorrow. Just give me a second. Okay, I've shared the book for the time series, right?
Yes, sir.
Yes, sir.
Okay, so guys, that is a very handy book. Example है उसमें, and the data set can also be very easily found online. I was looking for the package of the data set that basically it uses from the library, but on my RStudio, this version does not have that package. So, but you can easily use it even manually. There is no need. अगर package नहीं भी होगा तो कोई ऐसा worry नहीं है. So that is a very handy book for time series. And I'll just use that data as far as our today's lecture is concerned. Just give me some time. Okay, can you see my R Studio screen?
No, sir.
One second. Can you see it now?
Yes, sir.
You can see it, right?
Yeah.
Okay, all right. So what I want you to do, I want you to, one second. I want you to read a file into R from this website. It is from that book only, guys, so you can get it there as well. PSDL data dot MIC dot PAT. Basically, I want you to read this data on R. Just try.
Sir, can you post the link in comment box, please?
Yeah, yeah.
So it's throwing an error for me.
Yeah. Yeah. You see, if you actually if you go to the website and just check on this King's data set, what you see is that the first three lines exactly are not data. It is written as age of death of, this is the data set which gives you age of death of successive kings of England, and one name is there, and then the source is given there. So basically that's why it will be showing as error. So instead of that, first of all, what I do is I use this read lines for, so this is what I generally do whenever you download or whenever you're trying to load any file onto R. First of all, just read lines kar do, and this n is equal to 3 just gives you, first few, यहाँ पे मैंने 3 mention किया, you can mention 2, 5, whatever it is. It will just give you the observations, or it will just give you whether there are any text lines or what kind of observations or what kind of data is there. So that's why I always use read lines for, this is my preference. I'm not saying that you should do that. So if you run this, what you'll find is that the first 3 are not data, and after that the data set starts. So the next thing what I do is I store this URL as the URL, and then I store this other variable as tr, and I scan this by this scan function. So I skip first 3 lines. So now if you see, it will become, it will give you that data set because I have skipped the first 3 lines. So it gives me that. Now all of you have got this?
Yes, sir.
ओके सो अब मेरे पास ये डेटा सेट है, अब मुझे इसको टाइम सीरीज में स्टोर करना है. ठीक है, दिस इज जस्ट अ कॉमन आई जस्ट हैव a data file which just gives me age of death of successive kings of England, but this is not a time series observation as far as R is concerned. So in order to make it time series, we use the TS function, which makes जैसे हम LM function we were using for linear model, उसी तरह in order to store any data set as time series variable on R, we call the function TS. So we'll do the same thing as it is. So let us do that. So we call the TS function. Let me call as TRTS. TS TR. Now you see, this is the argument of time series function. So first is your data file, जिसको भी आप time series बनाना चाहते हो. Start is कि कब से start हो रहा है, end is कब से end हो रहा है. Frequency by default it takes a frequency equal to 1. जब पर अगर आपका monthly that is 1 stands for yearly, but if you have monthly data your frequency becomes 12. If you have quarterly data your frequency becomes 4. If you have yearly data frequency is automatically 1. So basically I do not have here yearly, quarterly data, anything, so I just keep 1. So TSTR, let me say that let me give any any number. So let me say this is 1946 1. So I'm saying that my data starts from January 1946 and then let me mention frequency. If I do not mention it will automatically take it 1. So let me just stop here. So now if you see this, if you plot, and I can simply use plot TRTS. So this is your data set. You can use any time. It is just this is the command. अगर आपको यहाँ पे end date भी mention करना है तो आप end date भी mention कर सकते हो. Frequency अगर आपका अलग है, आपका quarterly frequency, you have to mention frequency is equal to 4. If you have a monthly frequency, you have to mention frequency is equal to 12. By default, frequency is always in the time series function is taken as 1. Is this clear? यहाँ तक have you all got?
Sir.
हाँ जी.
So could you repeat just what have you done with the codes?
यहाँ पे?
Yes, sir.
Okay. See, first of all, this is the data set that I have, right? TR. I want to convert or I want to store this data set as time series variable on R. ठीक है? So in order to convert a normal data set into time series data set, what we do, we store that data set by calling TS function. So this is my TS function. TS I'm imposing on what? I'm imposing on my data set TR. Then I'm mentioning the date. That is, ये जो time series data है वो कब से शुरू हो रहा है. So what I'm mentioning here is that it starts with the year 1946 first month, that is January. I can also mention the end date. Here, since I have very less data, I have not mentioned it. But you can also mention the end date. And why I have used C? Because this is a vector.
And so what does the TS function do?
TS stores a data into time series format.
Okay, got it, sir.
ठीक है, अब जिसे आप प्लॉट में देखो तो what it is here, this is your age of death of successive kings of England, and on the x-axis you have time. So first king, second king, third king, fourth king, fifth king, sixth king, seventh king, eighth king, ninth king. ठीक है?
Yes, sir.
All right. So just by looking at the data set, can you see anything, whether the data is stationary, non-stationary?
Sir, I guess it's non-stationary.
Okay. And more or less, you can also see that, you know, along this part, so in the initial part, from here till here, then you can see a definite pattern from this part